In this lesson, we're going to look at counting techniques. Our objective: understand how to use a tree diagram, understand how to find a permutation, understand how to find a combination. Our vocabulary: tree diagram, showing possible outcomes using a branch for each choice. Permutation, arrangement where order matters. So A, B, C is different than C, B, A. So when you pick something actually matters here. A combination, arrangement where order doesn't matter. In this situation, A, B, C is the same as C, B, A because you've got the same three things, and the order that they came in doesn't really matter. First thing that we want to look at is a tree diagram. So I'm just going to go through an example. In this tree diagram, we want to figure out how many combinations this restaurant has if there are 2 types of entrees, 3 types of drinks, and 2 types of desserts, and you can order any combination of the 3 groupings. So we'll start with the entrees, and there are 2 types. So we're just going to cut or make 2 branches of the tree, and then we can choose 3 different drinks after we choose our 2 entrees. So we have 3 branches off of each branch, and then after we choose our drinks, we can choose 2 desserts from each of those. And what we've created is kind of branches coming out, and each last branch is the total number of possible choices. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Well, there's actually a quicker way of figuring out the total for this, and it's the counting principle. And the counting principle just says we can do A times B times C times however many options there are. So in this situation, what that means is there are 2 entrees, so that would be our A, 2 times 3 drinks, that would be our B, times 2 desserts, that would be our C. 2 times 3 is 6, 6 times 2 is 12, which is how many we got from the tree diagram. So this tree diagram was to help you understand the counting principle, but sometimes drawing the tree diagram will help us in the long run. Okay, there are 2 other types of grouping methods that we can use to try and figure out what's going on. The first is known as a permutation. In this, the order matters. So if I pick something first and then another thing second, that's different than if those 2 were swapped. So what I have here is an example. The way that we write a permutation is this N is our total number of options. This R is the amount of times we're going to do the process. And then P tells us it's a permutation where order matters. So our example is that we have 6 coins in our pocket, $1, $half-dollar, quarter, dime, nickel, and penny. We want to pull 3 coins out at one time, or pull 3 coins out one at a time. So if we pull the dollar coin out first, that's different than if we pull the dollar coin out third. How many possible groupings? Well, the way we do this is we write it like this. There are 6 possible coins that we can grab. We're looking for a permutation, and we're going to grab 3 coins. So what this means is this 3 tells us how many spots we have to fill. So we have 3 to fill. We're always multiplying in this situation. And this number tells us how many go in the first spot. And we just count down from there. So 6, 5, 4, and we keep filling in spaces until they're all filled in. So we have 6 times 5 times 4 for this situation, which is 30 times 4, which is 120 permutations. There are 120 different permutations or groupings here by pulling out the coins where order matters. Alright, we're going to do the same problem, except this time the order's not going to matter. Then we have a combination. Only difference in a combination is it has a C here. What this means is the order does not matter for the coins. So if I pull 3 coins out all at once and just look at what's in my hand, what's first, second, or third, doesn't matter. They can be switched around and they're all going to count the same. So again, we have the same idea, just in a combination. So in this situation, what we do is a little bit different. We take the permutation divided by the permutation of how many spots there are. So since this is 3, these are both 3. So then we're going to do the top. And the bottom would be 3 times 2 times 1. So this top, we've already found that that permutation is 120. The bottom is 3 times 2 times 1, which is 6. So we have 120 divided by 6, which is 20 combinations. If the order doesn't matter, there are 20 different combinations that can be made here. Alright, we've looked into the basics of how to figure out how many different options there are when we're counting in different situations, whether it be using a tree diagram, whether it's a permutation or a combination. If there are any questions or things that you missed, make sure you pause, rewind, and rewatch, and bring your questions to class. Thank you.